All right. All right, so bottom to top, y values. The red one is the lowest one, so it's going toward what? Negative infinity. So we know we're starting there. We go up here, and then we get to that spot, and we know, oh, that's an open circle, so that means there's a y value that's not being used. That y value is -1. Is -1 as a y value being used by any other piece? No. So we're getting to -1, and we got to skip it. Where's the next y value that's used? Go up, reading up, there, right there, it's 0, right? That vertex of that happened to be the next one. So 0 is we're going to pick up. What should I put there? Bracket, because it's used. And then if we go up this direction, we get an empty spot at 4. Is 4 being used as a y value anywhere else? Yeah, it's covered over here. So 4 is not being skipped. We keep going up toward what? Infinity. There are no more skips in there. So there's our range for that one. Let's get our intercept. 0, 0, right? It's the only place it's touching an axis. That's doable. What if you wanted to find intercepts and you didn't want to have to go through the trouble of drawing the graph? How do you find X intercepts? Plug 0 in for Y. So we could set each part equal to 0 and get an X intercept. But we then have to check to make sure that that X intercept is in the domain of that part. So if we plugged in 0 for Y on the -3x plus 5, if we set that equal to 0, we would find that X should be 5/3, which is 1 2/3. Is 1 2/3 fit X is greater than 2? No, 1 2/3 is less than 2, so it doesn't fit the domain for part B, right? So that's why it doesn't show up on the graph either. Notice the red line is not touching the x-axis because the domain cut it off. You can still, so if we want to find y-intercepts, we plug in x is what? 0. That's where the domain tells you which one to plug that into. The domain's going to tell you which one to find y-intercept from, because you need the one that x being 0 works in, which would be the part A for this one. So that's why 0, 0 happens to be our only intercept for this one. You can find all of these things without drawing the graph. The graph does make it a lot easier, though. I want to show you how to kind of use your graphing calculator to help you draw the graph. It will do this in a pseudo way that's kind of neat. So y equals on your graph, and you've got to use parentheses and a little something you've never used before in calculator. I'm pretty sure. So what you're going to do is in y1 you're going to put the first part. So I'm going to parentheses and I'm putting x squared, and then I'm going to close those parentheses. Then open up another set of parentheses, and this is where I've got to put my domain. So I'm going to put x, and then here's where you have to get the inequality symbol. To get the inequality symbol, you hit second math. It takes you to the test menu. We need a less than symbol, which would be option number 5. And then we put our number 2. Close those parentheses. I'm going to graph just that part so we can see that we're graphing just that part and show you what your graph calculator does. There's that parabola that we drew. Notice it flatlines the x values. So what that is, your calculator saying we're not using those for y1. We're just not using those x values. Okay. Now, go to y equals, put part B into y2. So a set of parentheses, -3x plus 5, close the parentheses, and now we need to put x is greater than 2. So x second math, option 3, and hit graph. And there we have the parabola. This red line says, okay, we're not using the x values that direction. Here's that. Now, here's the only hold up to that is you don't see an open circle or a filled in circle out of that. It exists on there. So if I know that there's open circles at +2, right? So if I hit trace 2 and hit enter, is it +2? And I want to jump to notice. Trace traced out of it. All right. Notice where it puts it. You can't see that. I mean, hide that. All right. It's down here on the line. It means it's not used by either of those. Out of that. So there's how it's indicating that that's an open circle. It doesn't put it there on the graph. So your graphing calculator has the ability to do these piecewise, but it's a little bit of a we're kind of halfway doing it here. We can't put the open circles and stuff just because it doesn't have that ability, but it does, actually not use those. All right. Now, continuity. Is this continuous or discontinuous? Discontinuous. Discontinuous. Understand? Discontinuous. All right. Back up here so we can see it. All right, next one. F of x is equal to 2 plus x. X is less than 0. Let's do x squared plus 4 for 0 is less than or equal to x is less than 5. And then let's do x cubed for x's that are greater than or equal to 5. 3-part. A linear, a quadratic, and a cubic. All right. Important point for part A. Zero 2. Okay. Draw my coordinate plane here. And I'm going to go to 0, 2 and put what? Open circle. Because it is not equal to. And then slope would be +1, right? So that means I'm going to go which direction? Remember, it's x's that are less than 0, so that would go this direction, right? So for a +1 slope, I've got to count down 1, left 1, right? Down 1, left 1. All right. Next part, important points.
0, 4, 5.
All right. 0, 4, so we're plugging in that. And then plug in 5. 5 squared is 25. Plus 4 is 29. So that's way on up there. Kind of 29. Do it. What about the point on 0, 4? Closed this time. 4 closed. And then 529. So that's way on up here. May not be able to fit it. So. Yeah, so yeah, exactly. Because I've got 2 x values on my domain. As Hunter said, we're going to plug in 0 to get the first one. And then we're going to plug in 5 to get the second one. So anytime you've got a compound inequality like that, you've got to use both x values because those are going to be the start and the finishing spots for that part. Okay. Now the in between, we've got to figure out kind of how much curve to put on that, because we know an x squared graph's got some curve to it, right? It's not a straight line connecting these two. So if I go to 5, 1, 2, that's way up here. Open circle on that. So it's way off there. You may not be able to fit it. It's okay. We're just going to get the idea here. Now, what's going on between 0 and 5? There's some x values there, right? So to get a better idea of how much curve to put on it, just plug in a couple of them, of the x values that fit into there. What are some x values that fit into that? 2 does. So 2 squared is 4. 4 plus 4 is, try again, 8. So count. Close circle on that. We could plug in 3. 3 squared is 9. 9 plus 4 is 13. So we get an idea of what that's doing curve-wise. Little hacky there. That's a big piece. As you see, all the way up there to the open circle. We could have plugged in 4 and got the ordered pair for that. You don't have to plug them all in. Just get a general idea. I'm not going to be extremely, I'm not going to check every single ordered pair out of that. General idea here. All right, so next piece. Let's change that to negative x cubed. We can go the other direction. Again, we put an open circle on the 529 because it didn't have an equal to mark. So here we're going to plug in positive 5. 5 cubed is 125, and it's negative, right? So we would be way down here. And I would, I'm just going to, that's about right there, right? And we know that that's going down, right? And we plug in 6 and get an ordered pair. 6 cubed, 6 times 6 is 36, times another 6, 180 plus 36, 216. Well, 6 times 30 is 180. You all do that, right? 6 times 3 is 18. Put a 0 on it. And then 6 times 6 is 36, and you add it. Yeah. So, and then, so 216, that's going to be way down here. So we'd go down there. All right, so we got that kind of picture going. So we got a lot of pieces out of that. So this is one of those where, hey, the graph's huge. We should have changed our scale. Gone by 5 or something like that. Probably would have been a good idea. All right. All right, let's talk about domain. I can't tell. I just made that one up off the top of my head. What's the domain of this guy? Start at negative infinity because our red line goes out this way. We get to 0. Is 0 covered? Yeah, it's used there. So we're not skipping it. Green one, we right along till we get to 5. 5's an open circle, but is 5 covered by anybody else? Yeah, it's covered by this one, so we're not skipping it. So 5 isn't skipped. And then the x cubed, negative x cubed, it keeps going. It's slowly inching toward positive infinity. So this is one that doesn't have any skips in the domain. It's a negative infinity to positive infinity. And then range. Again, we're reading from bottom to top, so we know that this piece down here continues toward negative infinity. And then it gets to this point. What is that point again? 5, negative 125. That's what that point is. And then, so we're going from negative infinity. But what about the red one? What does it do? It keeps going further down. You know, it doesn't have any stopping spots, right? It just keeps going down toward negative infinity. So is the all of these numbers between negative 125 and up here, are they covered? Yeah, they are. So we're not skipping any y values. We get up here, there's the first place that we got some issue. What's the y value right there? At 2, right? So the y value at 2 has got an open circle on it. Is it covered by any other y values? No. So we're skipping the 2. Where's the next y value that's being used? At 4. And how high does it go up? It goes to 29. Is 29 included? No. So our range goes from negative infinity up till we get to 2, and then it just jumps up here to 4, and then only goes to 29 from there, and doesn't use the 29. So there's the range, a little bit different on that one. Intercepts. There's only one at 0, 4. And continuity. It's discontinuous. Oh, it does, doesn't it? Where does it cross the x-axis at? Negative 2, 0. Our red line crosses the x-axis there. Good job. Way to go. All right, one more. I don't know. I wrote G, but it's actually example D. The function is G of X. We'll just do a two-parter. 2 parts on this one. 5 minus X from negative 3 is less than or equal to X is less than 1. And then the square root of X minus 3 for X's that are greater than 1. So the square root is just over the X. The minus 3 is on the outside. Usually I'll put a little tail there, and I just didn't do it. So that says square root of X and then minus 3. Okay, so just 2 pieces on this one. I think we're getting the idea. Important points for the first part. Negative 3, 8, because 5 minus negative 3 is 8. And then 1 plugged in, 5 minus 1 is 4. So 1, 4. Okay. Let's see if we can get the domain before we graph it. I think that's a good skill to have. Yeah, it's a good skill to work on. Because sometimes you're just going to be asked for the domain for these, and if you don't need the range, you know, for the problem, then why graph it? Because you've got the domains written. What's the lowest X value? Negative 3. Is it used or not? So that means we're going to put a bracket, negative 3, right? What's the next X value that we need to check? 1, because that first domain goes up to 1. Is 1 used in part A? No. So we're thinking there may be a 1 parenthesis right here. But when we look at part B, is 1 used? No. No, it doesn't have equal to mark there either. So that tells me that 1 has what? Open circle on the graph, right? So we're trying to visualize what the graph would do. So we know we are skipping 1. And then all of these X values go toward what? Positive infinity. So there we got the domain without the graph, which is a good skill to have. They give you all these domains over there on the right. That's how we're going to build the domain for the whole thing. We've been looking at the graph, which is a great way of doing it, but it takes a lot longer to graph that thing. If you just need the domain, you can get it from there. Green?
When you don't do the graph, how do you know like that you pick back up those ones?
All right, so when I got here, what does that tell me about the x's? It's all x's that are what to 1? Greater than 1. So that means that tells me to pick back up. It is possible that they could do that. That would tell me I don't pick back up. And that, if that were the inequalities, the domain of this thing would change from this stuff into that. Because we didn't use 1 here, but we used it here. So we don't have any skips in there. So they can actually put an equal to mark there and not an inequality symbol.
What would it look like if we like?
It'd just be a dot. That one spot. One ordered pair. So I'm going to go back to what we had before. All right. Now range is a little more difficult to do without the graph. I don't usually do range without the graph. You can do it. You just got to think about y value and what direction things are going. It's sometimes a little tougher to visualize. So we'll go ahead and graph it so we can get the range and the intercepts and all that stuff. Actually, let's get the intercepts without graphing. Because you guys are smart. Okay, to get an x-intercept, we're going to plug a 0 in for y. Okay, so if I set the first one equal to 0, 5x or 5 minus x equal to 0. That'd be negative x is equal to negative 5. That'd be x equals 5. Does that x-intercept exist for this one? No. 5 minus x is the first part. What's the domain of the first part? It goes from negative 3 up to 1. 5 is not in that. So that's not an intercept. Okay? If I set square root of x minus 3 equal to 0, I get square root of x is equal to 3. How do I get rid of the square root? Square. Is 9 in the domain for that piece? 9 is greater than 1. So that means, hey, 9, 0 is an intercept. That gets us x-intercepts. How do we get y-intercepts? Where do we do that? Which piece gets a 0 for x? Which one does 0 fit into the domain of? The top one, because the domain says it starts at negative 3, goes to 1. The other one starts at 1 and goes up. 0 definitely is not bigger than 1, so we have to use 0 in the first part. So if we plug in 0 into 5 minus, that's going to get us a y value, so that'd be 5. So 0. Those are our intercepts. They can be found without the graph. Does the graph make it easier? Yeah, sometimes, if you can graph it right. I'm surprised how many times folks don't graph things right. But that's okay. But we're learning. Part of learning is messing up, right? All right, so let's go ahead and draw the graph, and then we'll get the range and continuity of this thing, and we'll be done. All right, so first ordered pair that we're going to plot. Negative 3, 8. So I'm going to go to negative 3, 1, 2, 3, 4, 5, 6, 7, 8. Why did I put a filled in dot? Because I like coloring. No, because it's got an equal to mark. What we put at 1, 4. Open circle because it doesn't have an equal to mark. What does that graph look like in between? 5 minus x. Is that linear or is it curved? It's not in slope-intercept form, but it could be easily moved to where it is, right? It's negative x plus 5, right? So that is a straight line between those. Do I need to count my slope? Do I have to? I could go up one, left one, up one, left one, up one, left one, and I end up at the same spot. But it's a straight line. Just connect the dots. Shortest distance between 2 points is a what? Straight line. You can't always go that direction. But for this one, because it's a linear equation, that's what we want to do. If it were not linear, you would need to plug in some x values in between the -3 and the 1, just so you can get a better picture of how, where the curve goes. Estimating it's always good, but some of us are better estimators than others. And, so plugging in x values, you actually get the right ordered pairs. Now, where's the next spot we're going? We haven't found the important point for part 2 yet, or part B. So 1 and 1, square root of 1 is 1. 1 minus 3 is -2. Good job, Lonzo. All right, so 1, -2. Open, filled in. Open. And we know that the square root of x, what's the general shape of square root of x? It's kind of like a sideways parabola, right? It's like a half of a sideways parabola. So it kind of does this kind of shape, right? How can we get a better picture of that when we graph it? Because all our x values go which direction? Toward positive infinity, right? We know that from our domain too, right? So I'm going to pick some x values that are easy to work with. What are easy numbers to take the square root of? 4. What's the square root of 4? 2. 2 minus 3? 1. So, all right, so -1. So go to 4 as the x value. My y value is -1. What's another number that's easy to take the square root of? What's something smaller? 9. 9, the square root of 9 is 3. 3 minus 3 is, oh, that works out nice. Okay, so that's 4, 5, 6, 7, 8, 9, 0. That gets us a pretty good idea what the graph is doing. Now, got that going? We knew it should cross the x-axis at 9, 0, right? Because we already found that, right? And then we know it's crossing the y-axis at 0, 5. We see the blue part doing that. We found that before we even do it. Drew the picture. Let's get the range of this thing, so we can get the. I think we know the continuity of this thing.
What's the range?
Bottom of the top. -2 with a parenthesis. Good. Because going bottom of the top, this is the lowest y value on the red part, and it's not used. It's open circle. So we got a parentheses with a -2. This, how far is the red part going to go? It's going to keep going up forever. So it's going to go to positive infinity. So is it going to cover this open circle here? Eventually. It'll take it a long time to get there, but it will. And then this one stops right here, but the red one continues forever. So it's going to outrank the blue part stopping at that spot, right? It'll be a long time before the red one gets higher than that, but it will get there. So this one is going to go up to positive infinity from -2. All right. Not bad. This is not rocket science. All right, so we got 5-6 minutes left in class. Starting 248, 9 through 49 is the problems we're looking at. Again, we're out Monday for Martin Luther King Day, so Tuesday will be a work day when we come back. I would suggest at least doing 1 or 2 problems or rewatching the video before you come in Tuesday morning, so that you're not sitting here trying to start over on Tuesday morning, because I really don't expect any of you to do this over the weekend. surprise you, if you will. But I would suggest at least rewatching the videos over the weekend so that you're not coming in just blind, or if you get here early, watch the videos while you're sitting here waiting. So, all right.